No, let's start. See, this lecture is about the numericals of unit hydrograph and direct runoff hydrographs. Okay, so see the first numerical. Average rainfall of 16 centimeter occurs over a catchment during a period of 12 hours with uniform intensity. See, these words are important. With uniform intensity. See, these words means uniform intensity. The 6-hour unit hydrograph of the catchment rises linearly from 0 to 30 cumecs. This is linearly stated here. From 0 to 30 cumecs in 6 hours, and then falls linearly from 30 to 0 cumecs in 12 hours. The phi index is given as 0.5 centimeter per hour and base flow as 5 cumecs. Find the peak discharge of the resulting DRH, direct runoff hydrograph, and find the area of the catchment. Okay, so how to do? Let's start. What we are required to do, find the peak discharge of the resulting DRH. Okay, direct runoff hydrograph. We need a direct runoff hydrograph, and what is given to us? This is given to us a 6-hour unit hydrograph of catchment given rises linearly from 0 to 30 cumecs. See, I have given here. This is a graph of discharge versus time. This is the hydrograph. A unit hydrograph is there. So 6-hour duration precipitation occurred here. Okay, a 6-hour duration precipitation occurred here, and for this intensity of precipitation will be 1/6. So the unit hydrograph of 1 centimeter total precipitation occurred. Okay, now see what is written here. Uniform intensity, the 6-hour unit hydrograph of the catchment rises linearly from 0 to 30 km. As it is stated as linearly, so we will draw this like this. Okay, straight line from 0 to 30 cubic. So this is 0 to 30 cubic, this is 30 cubic. Okay, this is of 30 cubic, this one is 30 cubic meter cube per second. This is the discharge here, and falls from 30 to 0 cubic, 30 to 0 cubic in 12 hours. See, 0 to 6 hours is this portion, in this portion 0 to 6 hours, and from this to this it is 12 hours. 12 hours means 6 to 12 hours means total equal to 18 hours. Okay, total 18 hours. So this one is 0, this one is 0 time. After that is this is 6, this is 12 hour, and this is 18 hour. Okay, this hydrograph is given to us, where the peak discharge is stated as 30 cubics. Okay, and this hydrograph is of unit hydrograph, so it must have precipitation of 1 centimeter. You can understand this. Now what we have to do, find the peak discharge of a resulting DRH. So now resulting DRH, what is the DRH? See, average rainfall of 16 centimeter occurred over catchment during a period of 12 hours. 16 centimeter is the depth of precipitation, is the precipitation depth. Now we need DRH, means direct runoff. So for direct runoff we have to deduct from precipitation the infiltration, isn't it? If we deduct the infiltration from precipitation, then we will get the runoff. So phi index is given for this reason, 0.5 centimeter per hour. So 0.5 centimeter per hour, then in 12 hours how much infiltration occurred? In depth it will be 12 into 0.5, it will be 6 centimeter precipitation, 6 centimeter infiltration, sorry. So 6 centimeter infiltration occurred in this 12-hour duration, and precipitation was 16 centimeter. So what was the runoff? It will be 16 minus 6 equal to 10 centimeter, isn't it? I'm repeating another time. See, the phi index is given as 0.5 centimeter per hour. Okay, so 12 hour total 12 hour precipitation occurred, so per hour 0.5 centimeter, then total infiltration was 12 into 0.5 centimeter. 12 into 0.5 means equal to 6 centimeter infiltration occurred. So if 6 centimeter infiltration occurred and 16 centimeter precipitation occurred, then what is the runoff? Then 16 minus 6, then it will be 16 minus 6, then it will be 10 centimeter of runoff. So we need to find the peak discharge of 10 centimeter DRH. Okay, this we needed. So now we are given a unit hydrograph of, Okay, unit hydrograph given, its peak discharge is given as 30 cubic. Now let's we tabulate it like this. See, from the first 0 hour the discharge was 0, in the 0 it was discharge was 0 in the 0 time, in 6 hours time it was 30 meter cube per second. Okay, in 12-hour time it is 15. How I have written, I am just showing you. In 18 hour it becomes 0 another time. Okay, see, this is a triangle, this one is a triangle form. Okay, and it is stated clearly that the unit hydrograph rises from 0 to 6 hours linearly from 0 to 30 cumex, and then linearly also in 12 hours it falls from 30 to 0 cumex. So as it is a triangle, then from the equivalency of the triangle, I can write it as 6 to 12, 6 to 18 means 12 hours, 12 means 30 divided by 12 equal to this, equal to x divided by 6. Okay, from here I can get this. Okay, I can get this as 15. So I have written it like this. Okay, now see, we have a 12-hour duration storm, but here a 6-hour duration unit hydrograph given. So we need to draw another 6-hour duration unit hydrograph. Then we have to add this. Then we will get the unit hydrograph of 12-hour duration. Okay, then after that the 12-hour duration direct run of hydrograph we can get. Okay, this will the process of our proceedings. Okay, see what we are doing. Write the ordinate in the tabulation form. Okay, 0, 30, this is in meter cube, this is time in hours. Now lagged by 6 hours. What is by this? Lagged by 6 hours means if another suppose we need a 12-hour storm, okay, and a 6-hour unit hydrograph is given, so another 6-hour storm will contribute to 12 hour, means a 6 hour is given, another 6-hour storm if happen after this storm, then it will be resembled by 12 hour. So what we needed actually 12-hour storm, so we have lagged this by 6 hours. See, we have lagged this. In the next step, we have lagged the unit hydrograph by 6-hour duration, means the ordinate from 0 to 18, now the ordinates become 6 to, this one is 24th hour. So the next hydrograph will be from started from 6 hours and ending in 24 hours. Okay, so this is given here. We have lagged it by 6 hours. Why? Because the next 6-hour storm will contribute the first drop of rain after the first 6-hour storm. After the first 6-hour storm happened, or after the first 6-hour storm occurred, after then only the next 6-hour storm's first drop will contribute to the discharge. So we have lagged this by 6 hours. So this if we add this, these two ordinate, if we add, then we are getting, oh sorry, this is lagged one, and this if we cumulate this one, these two, if we cumulate these two, then we are getting 0. See, 30 plus 0 equal to 30, 15 plus 30 equal to 45, 0 plus 15 equal to 15, and 0 plus 0 equal to 0. This one is therefore the cumulation of the two hydrographs, means 12-hour DRH. We have got the 12-hour DRH. Okay, this one, adding these two ordinates, we have got a 12-hour DRH. So if it is a DRH, then it must not have a 1 centimeter precipitation, then it will have, see, the first hydrograph is a unit hydrograph, so it has a 1 centimeter precipitation. The next hydrograph is also a 1 centimeter precipitation. If you cumulate these two, then we will have a 2 centimeter precipitation. Okay, so we get a DRH of 2 centimeter precipitation. Now we need to have a DRH of 10 centimeter precipitation. How the 10 centimeter comes, we have just calculated earlier. See here, 16 centimeter was the precipitation, 0.5 into 12 was the infiltration. If we minus this, if we deduct this, then we are getting 10 centimeter actual direct runoff. So now we are getting the DRH of 2 centimeter but we need a DRH of 10 centimeter. So multiply this by 5, you will get, multiply this one by 5. Sorry, see, cumulate 2 centimeter direct runoff hydrograph we have got 2 centimeter. Now we need 10 centimeter, so just multiply this with 5. Okay, see, 5 into 0 equal to 0, 5 into 30 equal to 150, see, 5 into 45 equal to 250, 225, 5 into 15 equal to 75. Okay, 0 to 5 equal to also 0. Okay, how I calculated this, I am repeating another time. Okay, we need a DRH. See what is in the question. Find the peak discharge of resulting DRH. What was the resulting DRH? DRH was resulting in a precipitation of 10 centimeter. So we need a 10 centimeter precipitation DRH. Okay, adding the 2 unit hydrographs, we were getting the 2 centimeter DRH. Okay, if we divide this by 2, then we are getting a 12 hour duration unit hydrograph, means 12 hour duration precipitation, and the depth of precipitation equal to 1 centimeter. If we divide this by 2, then after that if we multiply this by 10, then we are getting the same one. You can jump from this step also, that you are getting a 2 centimeter precipitation here, and if you need a 10 centimeter precipitation here, then you have to multiply this by 5 only. So from here we are getting a peak discharge as 225 meter cube per second, and this was in the question. Find the peak discharge of the resulting DRH. That is done here. So this is the answer. Okay, let's go to the next page. See, we have to calculate what? Now the area of the catchment. Okay, we have to calculate the area of the catchment. Let's zoom out a bit. Okay, unit hydrograph of 1 centimeter depth we have. So 1 centimeter depth unit hydrograph we have already we have 1 centimeter depth unit hydrograph. Now 1 centimeter depth will be, how we have get it, that this one is the area of under the hydrograph. So this one is the volume in meter cube, and this one is the area of the catchment. So meter cube by meter square equal to, in meter it is converted in 1 centimeter, so this is 0.36 is written here. Okay, so we have to, if we need the area here, okay, we have got the hydrograph there. Okay, and we have got the unit hydrograph, so 1 centimeter depth. So if we need to area here, from this equation we can easily calculate this. See how we have done it. 0.36 into, why it is 6 written here? Because for 6 hours, O into T, this is O, this is O, ordinate into T equal to duration of time. This is 6 into 0 plus 15. This one is the ordinates. This one, it was the ordinates in the hydrographs we have just discussed above. Okay, 15, 22.5, 7.5 and 0. If we divide this by 1 centimeter, then we will get area in kilometer square, 97.2 kilometer square. Okay, from the direct runoff hydrograph we can also calculate this. See here, 10 centimeter was the direct runoff. Okay, this one is the depth. Take this here and take this one here. Now 0.36 into 6 hour duration, and the ordinates, follow the ordinates from the direct runoff hydrograph just calculated. 0, 150, 225, 75, like this. You will get the area also. Understood? Okay, now comes the next one. The ordinates of a 2 hour unit hydrograph is given. The ordinates of a 4 hour unit hydrograph at the time of 3 hours. We need to know the ordinate of the unit hydrograph at the time of 3 hours. What will be? See, the ordinate of 4 hour unit hydrograph. Now it is given as 2 hour unit hydrograph. We will lag it by 2 hours. lag it, we will lag it by 2 hours, then we will get the 4-hour unit hydrograph. 4 hour, see how we have done it. See, time versus discharge is written here, what is given in the question, this one. 0 time, it was 0 discharge. In the first hour it is 5 meter cube per second discharge, in the second hour it is 12 meter cube discharge, third hour it is 25 meter cube discharge, and this is given in the question. Okay, now see what we need. We need a 4-hour unit hydrograph, means 4-hour duration storm. Okay, so after 2 hour storm, the next 2 hour storm will start, then it will be converted to 4 hour, isn't it? So after 2 hours, see 1 hour, 0 to 1 equal to 1 hour, 1 to 2 equal to 2 hour. Then after 2 hours we have started to draw the unit hydrograph. Okay, so unit hydrograph was given here, the duration was 0 to 1 hour, 1 to 2 hour, but we need the 4-hour storm here. So the 2-hour unit hydrograph is given. After the 2-hour unit hydrograph completed, then only the 2-hour storm started another time. So after 2 hours, means first hour, second hour, then 2 hours, the lagged, then the ordinate repeated here. See, from 0 to 1 hour, after that 1 to 2 hour, the ordinates repeated. See 0 here, then 5 here, then 12 here, then 25 here, then 41 here. Okay, and we have lagged it 2 times, because what? Because the duration of rainfall needed is 4 hour, and after 2 hour duration, then after 2 hour duration the precipitation started. So we need the 2 hour duration to be stopped. Okay, so here this is, so now cumulated, this two is cumulated here. Okay, this 2 is cumulated here. So it will result a 2 centimeter precipitation, because this one is a 1 centimeter precipitation runoff, 1 centimeter depth of runoff, and this one is also 1 centimeter depth of runoff. So if you cumulate these two, then we will get a 2 centimeter runoff. So this one is 2 centimeter. We need a unit hydrograph. In 4-hour unit hydrograph, we need a 4-hour unit hydrograph. So for unit hydrograph, we have to divide this by 2. We have divided this by 2, this ordinates. See, 0 divided by 2 equal to 0, 5 divided by 2 equal to 2.5, 12 divided by 6, 12 divided by 2 equal to 6, 30 divided by 2 equal to 15. Now we need in the third hour, what will the peak discharge? This one is a 15, this one is the answer. Okay, now see the next question. See the durations. So what is written here? See the duration given here 1 hour. So lagging by 2 hour needs to be skipped by 2 ordinates, not 1. Okay, as the duration is of 1 hour given, so 1 hour, what is 1 hour? 1 hour is the discharge, in the lag of the discharge. Okay, the duration of lagging of discharges. Okay, but we need to lag the hydrograph, not the discharge time intervals. Okay, so for the discharging, for lagging the hydrograph, means to lagging the precipitation. Okay, so to lagging the precipitation, we have to assume that after the 2 hour storm has occurred, after the 2 hours, then the first drop of the rainfall has occurred. So we have to lag the hydrograph by 2 rows. Okay, now see, an effective rainfall of 2 hour duration produces flood hydrograph peak of 200 meter cube per second. Effective rainfall of 2 hour duration, see, it is a 2 hour duration storm. Next produces a flood hydrograph. This one is a flood hydrograph. See, this one is a flood hydrograph. Peak of 200 meter cube per second. The flood hydrograph base flow equal to 20 meter cube per second. See, this is quite evident that 20 meter cube per second given as base flow. If the spatial average rainfall in watershed for duration of storm is 2 centimeter. Here it is the direct runoff stated as 2 centimeter. Not direct runoff, this is a precipitation depth. Now average loss is 0.4 centimeter per hour. So if it is 0.4 centimeter per hour, and the peak of 2 hour unit hydrograph we are required. Okay, now we are required a unit hydrograph from a DRH, not DRH, it is flood, from flood hydrograph it is needed. So what we have to do, See, first 0.4 centimeter per hour is the average loss, okay, and precipitation is total 2 centimeter during the 2-hour duration storm. So during the 2-hour duration storm, total infiltration loss equal to 0.4 into 2, isn't it? Total infiltration loss or other losses will be total 0.4 into 2 equal to 0.8 centimeter total, and 2 centimeter is the precipitation. So 2 centimeter minus, if we just 2 centimeter minus 2 centimeter minus 0.8 centimeter, sorry, 2 centimeter minus 0.8 centimeter, let me correct a bit, 2 centimeter minus 0.8 centimeter, then I will get the direct runoff as 1.2 centimeter, isn't it? If we deduct the infiltration losses from the precipitation, then only we are getting the runoff, isn't it? See here what we have done. Separating base flow, see, the loss is 0.4 centimeter per hour, total loss equal to 0.8 centimeter in 2 hours, so runoff depth will be 1.2 centimeter. Now the peak has given in the form of flood hydrograph, so we have to separate the base flow from here. 200 minus 20 equal to 180 meter cube per second is the peak of direct runoff hydrograph of 1.2 centimeter effective runoff, sorry. So we need a peak of unit hydrograph. So for unit hydrograph, we have to divide it by 1.2. The peak ordinate is given as 180. Okay, peak ordinate is given as 180, and 180 is peak ordinate of what? Peak ordinate of direct runoff hydrograph. So from direct runoff hydrograph, we need to calculate the unit hydrograph. From direct runoff hydrograph, we need to calculate the unit hydrograph. So for unit hydrograph, the depth of precipitation, depth of runoff must be 1 centimeter. So for 1.8 centimeter, if the peak discharge become, for 1.2 centimeter, if the peak discharge becomes 1.8, then for 1 centimeter, what will the peak discharge? Then 180 by 1.2. This one is 150 meter cube per second. This one is the answer. Okay, understood. Let's proceed to the next page. The ordinates of 1 hour unit hydrograph at 60-minute interval are given. This is 60-minute interval, means in 1 hour interval was given. Ordinates of a unit hydrograph, 1 hour unit hydrograph, 1 hour storm has occurred. A 2-hour storm of 4 centimeter excess rainfall occurred in the basin from 10 am. Considering constant base flow of 20 meter cube per second, the flow of the river at 1 pm will be see, 1 hour unit hydrograph is given here. 1 hour unit hydrograph is given here. Okay, now what happened? A 2-hour storm of 4 centimeter excess rainfall occurred in the basin from 10 am. So this is 1 hour unit hydrograph. If we need a 2-hour unit hydrograph, then we have to lag this by 1 hour. See, we have lagged it by 1 hour. Okay, means we assume that after 1 hour duration storm, another 1 hour duration storm occurred. Okay, so we have lagged it by 1 row. Okay, 1 hour. So 1 hour lagged, we have get another hydrograph, unit hydrograph. So if we accumulate these two, we get a 2-hour storm direct runoff hydrograph of 2 centimeter depth. We have accumulated 2 unit hydrographs, so 1 centimeter here and 1 centimeter here. We will get a 2 centimeter here. So if we divide this, we will get a 2-hour 4 centimeter, not 4 centimeter. See, if we divide this by 2, so we have multiplied this by 2, is a step jumped here. Okay, if we divide this by 2, see, if we divide this by 2, we will get a 2-hour 1 centimeter depth unit hydrograph, means 2-hour unit hydrograph. If we need a 4 centimeter DRH, then we have to multiply this by 4, multiply this with 4. See, you have jumped the step here. We have 2 centimeter precipitation of 2-hour duration. If we need a 2-hour 4 centimeter precipitation DRH, for DRH we have to multiply this by 2. See, we have what we have done here. 3 into 2 is 6, 15 into 30, 15 into 2 is 30. Now we have stated we need at 1 p.m. what will be the peak discharge, what will be the discharge ordinate, it is 40. See, it is 40 meter cube, but we need what, we need the base flow also, because we need what, consider constant base flow 20 meter cube. The flow of river at 1 p.m. will be flow of river at 1 p.m. 1 p.m. at what we have studied, that in the river the flow was base flow primarily. Okay, primarily was the base flow, constant base flow was there, that was 20 meter cube per second, and the peak discharge occurred here as this, at this one is 40. So total flow will be seen as 60 meter cube per second. Okay, at 1 p.m. See, in these type of questions, what we have to focus, we have to focus what is given and what we need. Okay, these two words are very much important. See what we have given. See, 1 hour unit hydrograph given. Now what we need, a 2 hour storm needs, see the 2 hour duration storm we need. So 1 hour have to convert it to 2 hour firstly. If we convert 1 hour unit hydrograph to 2 hour, then it will convert to a 2 centimeter storm. Then we have to convert it to 4 centimeter storm. So from 2 to 4 it need to be multiplied by 2. That is done here. Okay, let's go to the next problem. The drainage area of a watershed is 50 km square. The phi index 0.5 centimeter per hour and base flow equal to 10 meter cube per second. 1 hour unit hydrograph of watershed is triangular in shape. See what is given. 1 hour unit hydrograph is given firstly. So unit hydrograph means it will have a depth of 1 centimeter, and the duration of rainfall equal to 1 hour. See, watershed in triangular in shape with a time base of 15 hours. The peak ordinate occurs at 5 hours. The peak ordinate in unit hydrograph is, we need to understand what is the Q. So this is a unit hydrograph given here. Okay, a unit hydrograph given here. And it is triangular in shape. Okay, see what is given. Watershed 50 km square. The phi index equal to 0.5 centimeter per hour and base flow at the outlet equal to 10 meter cube per second. 1 hour unit hydrograph watershed is triangular in shape with a time base of 15 hours. So this one is of 15 hours. And the duration of precipitation was 15 hours. This one is 15 hours. And the time of precipitation was, it was 1 hour, isn't it? 1 hour duration. Okay. Now the peak ordinate occurs at 5 hours. The peak ordinate of unit hydrograph, it is need to be measured. Okay. See what we can do. Triangular in shape. We need the triangle shape actually. Okay, now see what we can do. N equal to 1 centimeter, area equal to 50 kilometer square. Therefore volume will be 50 kilometer square is given in the question, and unit hydrograph means 1 centimeter is the depth. Therefore 50 kilometer square into 1 centimeter, if we multiply this with, then we will get the total volume of the runoff, isn't it? The volume of the runoff, if volume of the runoff is nothing but the area of the triangle here, area of the hydrograph. Okay, now see what we can do. See, half, this area of the triangle means half into 15 in hours in x meter cube per second. It will we get as 5 into 10 to the 5 meter cube into 2 means 15 by 16 to 60. What we have done here, see, just how we have to do this. See, this one is the area of the hydrograph means half into base 15 r into height. We need this height actually, q. Okay, therefore half into 15 r into q equal to the volume of the runoff. What is volume? Volume equal to the 1 centimeter depth into 15 kilometer square. 1 centimeter depth means 0.01 meters, and 50 kilometer square means 50 into 10 to the 6 meter square. So this will contribute to total meter cube. Okay, this one will be total meter cube, and half into 15 hours into 3600 in seconds into x meter cube per second will give you the x value from this equation. Okay, from that equation you will get the x value in meter cube per second. So peak discharge is calculated from there. So this is written here. Just do it in calculator and report me in the chat box or message box that what we have done. Okay, you have understood what is given here. Now see, for the storm of depth 5.5 centimeter duration of 1 hour, the peak coordinate of the hydrograph will be, now the storm have duration depth of 5.5 centimeter. This not becomes now this not becomes a unit hydrograph. At first it was stated that we need the peak coordinate of unit hydrograph. Now the depth of precipitation becomes 5.5 centimeter. Now we have given the precipitation means infiltration as 0.5 centimeter per hour. So 0.5 centimeter is the infiltration and 5.5 centimeter equal to depth of precipitation. So if we subtract this one 5.5 centimeter from 5.5 centimeter, then we will get as the depth of runoff. This one is the precipitation depth, and if we deduct from here the infiltration depth, then we will get the depth of runoff. This is of 5 centimeter. Now we have get the peak discharge of unit hydrograph of 18.51 meter cube. Now if we need for 5 centimeter DRH, the peak will be 5 into this one, 5 into this one, and if we need the peak ordinate of the hydrograph means flood hydrograph, then we have to add the base flow also. What is the base flow? Base flow here is given as 10 meter cube per second. So thus we have calculated here, see, 5 into 18.51 equal to this, and with adding 10 we are getting as 102 meter cube per second. This one is the required answer. Okay, let's go to the next page. See, 1 hour triangular unit hydrograph of a watershed has a peak discharge of 60 meter cube per second. See here 60 meter cube per second is given. It is a 1 hour duration rainfall, and also unit hydrograph means it has a depth of 1 centimeter. And at 10 hour the peak discharge occurred at 60 meter cube and a time base of 30 total hour. The phi index equal to 0.4 centimeter per hour and the base flow equal to 15 meter cube per second. The catchment area of the watershed will be the catchment area. We need the area. Now see, we have the depth there, and we have a triangle here. So we need to calculate the area means volume divided by depth will give the area, isn't it? See, the area of this triangle means half into base into height. Height we know as 60 meter cube per second, and this one is the time base in hours, so we have to convert this also in second. So half into 30 in hours into 3600 in second, it becomes in second, into 60 meter cube per second will be the area of this graph, means the volume of the total runoff. Now volume divided by 1 centimeter is the depth of runoff, then we will get the area of the catchment. We need this, the catchment area in the watershed. Just do it, don't need to follow the formula, just do it with concept. Okay, now what is written? If there is a rainfall of 5.4 centimeter in 1 hour, the ordinate of the flood hydrograph at 15th hour will be, see, it is written as 15th hour, so we need to just assume, or we have to calculate the 15-hour peak here. What is the value of this? We need to calculate first. See, for 10 to 30 equal to 20 means 60 by 20 equal to 15 by x. We need to calculate the x. This one is 60 by 20 equal to x divided by 15. So from here x will be of what here we have calculated. See, x will be of 45 meter cube per second. See, this one is the for unit hydrograph. Now what we need? If there is a rainfall of 5.4 centimeter in 1 hour, Okay, now what is the infiltration loss? This one is a 0.4 centimeter per hour is the infiltration loss. So 5.4 centimeter minus 0.4 centimeter will be the infiltration loss, means direct runoff will be 5 centimeter. So for 5 centimeter, this hydrograph should be multiplied by 5 centimeter. So 45 will be multiplied by 5 centimeter 5. So see here 5 is multiplied into 14. As unit hydrograph we have already got the unit hydrograph, and we need the direct runoff hydrograph here. Not direct runoff hydrograph, we need a flood hydrograph, so we have to add the base flow also. See, we have added the base flow. What is base flow of time base flow of 15 meter cube per second? So we have to add this 15 meter cube per second here also. So see, 5 into 4, 45 meter cube per second, 225 meter cube per second. This one is the ordinate in the 15th hour of the DRH. Okay, now to add base flow, we will get the flood hydrograph also. We have added the 15 meter cube. Now we have get the 240 meter cube per second is the ordinate of flood hydrograph that we have needed. Now see the next numerical. The average rainfall for 3-hour duration storm equal to 2.7 centimeter. This is 3-hour duration storm. Just try to understand these words. Okay, 2.7 centimeter is the depth, and loss rate 0.3 centimeter per hour, means in 3 hours the total loss will be 3 into 0.3 equal to 0.9 centimeter. Now if we deduct this 2 point from 2.7, then we will get the direct runoff from this. So 2.7 minus 0.9 equal to it will be 1.8 centimeter. This is given here. This one is the direct runoff. Now the flood hydrograph has a base flow of 20 meter cube per second and produces a peak flow of 210 meter cube per second. The peak of 3-hour unit hydrograph we need. Now see, 210 meter cube per second is the peak discharge, is a peak flow of what? Peak flow of flood hydrograph. Okay, so from flood hydrograph we need to deduct 20 meter cube per second to get the DRH, direct runoff hydrograph. 210 minus 20 equal to 190 meter cube per second is the DRH. Okay, now we need the unit hydrograph. Now what was the depth? 2.7 minus what's the depth of runoff of DRH? Equal to 1.8. Direct runoff of 1.8 centimeter. So divide by 1.8 centimeter, it will give the unit hydrograph ordinate, isn't it? 190 meter cube per second have the discharge due to 1.8 centimeter of direct runoff. So for 1 centimeter direct runoff, means for 1 centimeter direct runoff we need a discharge here, that will be 190 divided by 1.8. That is the answer. Just calculate it with a calculator, you will get the confidence. After seeing the question, I will recommend you to calculate it by yourself. Okay, then after that just see the video, then you will be benefited. Okay, see what is given here. A DRH due to an isolated storm with an effective rainfall of 2 centimeters. See, these terms are important. Okay, this is the effective rainfall of 2 centimeters. This is rainfall, not runoff. Was trapezoidal in shape. The DRH is given here. Okay, and effective rainfall is given here as 2 centimeter. Effective rainfall means runoff. So runoff of 2 centimeter producing a DRH of trapezoidal shape. Okay, in shape is shown in the figure. The hydrograph corresponds to a catchment area in kilometer square. Now we need in kilometer square the catchment area. See, this area will correspond to the volume of the total runoff. This area will correspond to a volume of the total runoff. This diagram is given in the question. Okay, so this area will resemble the volume of the runoff. Now if we divide this by the depth of runoff, then we will get the area of the catchment. Then you can do by like this, the area of the trapezoid equal to half into parallel sides, summation of parallel sides, into height equal to, you know what is given here as 90 meter cube per second. Okay, so half into 4 plus 70 hours, 4 hour plus 70 hours will give you into 90 meter cube per second will give you the volume here, volume of the runoff. Then divide it by 2 centimeter precipitation, 2 centimeter DRH, then you will get the area in kilometer square. don't follow. I am recommending you not to follow the formula here. Okay, just do it by yourself with your concepts. See, this one is the area or volume. Now see, this one in hour and this one in meter cube per second. So hour to be converted, if you have to multiply this one with this, hour to be converted in seconds. So half into half means 4 hour plus 70 hours into 3600 will convert it to second, by 2 into 90 meter cube per second will give you in meter cube the volume in meter cube. Then divide it by 2 centimeter, not 2 centimeter, it you have to convert this in meter also. Then you will give then we will get the area in meter square, then convert it into kilometer square. This will be helpful to you. Okay, so bye for this lecture.